Welcome back to our discussion of derivatives in the real world. In this example, we're going to be talking about a farmer who's building a pig pen. And the farmer is deciding how big they want the pig pen to be. And so, a bigger pig pen will cost more money. And the cost of that works out, in terms of the number of square feet total for the pig pen, to be 40 times the square root of a. So here we have a function where the input is the area of the pen that the farmer wants to build, and that's in feet squared. And the output is the cost to build it in dollars. So let's just start with, just to get a feel for how this function works, let's think about c of 100. This would be 40 times the square root of 100, which would be 400. And what this is telling me is that a 100 square foot enclosure will cost $400. Okay, again, emphasis, I haven't taken any derivatives yet. I'm just talking about the function itself for now. If the farmer is also considering a 400 square foot enclosure, which would presumably hold 4 times as many pigs, then the cost of that enclosure would be 40 times the square root of 400. The square root of 400 is 20. This would be 800. Okay. And so what does this mean? This means a 400 square foot enclosure would cost $800. So as the farmer makes this decision, the farmer is thinking about, how much does it cost me to make my enclosure bigger? And is it worth the cost? And you can see a little bit of a hint of what's happening here in just the 2 points I've shown you, namely quadrupling the area of the pen only doubled the cost. So what that's really telling me in some sense is that as I make the fence bigger, making the fence even bigger is getting cheaper. But I want to try and quantify that using derivatives. So to do that, I'm going to write down the derivative of our function, which, since I've given you the function, we can just calculate. And it is 20 divided by the square root of a. And so that means that I can come down here now and I can calculate c prime of 100. And that will be 20 divided by the square root of 100, which is 20 divided by 10. So this will be 2. And what are the units? They're the units of the output over the units of the input. So this is dollars per square foot. And what does this mean? This means that if the farmer is currently building a 100 square foot fence, then each additional square foot the farmer wants to add will cost about $2. So if the farmer is currently thinking, 100 square foot pen sounds pretty good, and then let me think about, do I want to go up to 120 square foot pen? What would that cost? Well, currently the farmer is paying $2 for extra square foot. So that is to say, the farmer is currently looking at an extra $40 to add those 20 square feet to the pen. But what's c prime of 400? Well, I can go up to my formula up here. I get 20 divided by the square root of 400, which is also 20. And so this is $1 per square foot. And so what does this mean? This means that if the farmer is currently considering a 400 square foot fence, then additional area is only costing $1 per square foot. In other words, if the pen is already big, then making it even bigger is cheaper. Now, how does this change from 2 to 1? And again, this is like the speedometer thing. At this exact size of fence, an additional square foot of fence costs $2. But once I add an additional square foot, Well, now it's not quite $2 for an extra square foot. It's a little under $2. And then if I add another square foot, it's a little less still, until I've added 300 more square feet and get up to 400 square feet, at which point now I've gotten down a little bit at a time from $2 per square foot to $1 per square foot. And if I kept going, then as I added an extra square foot and an extra square foot to the 400 square foot fence, then the price of an additional square foot would go down even more to a little less than 1 and a little less than that and a little less than that, and so on. So these numbers are both very relevant in terms of the farmer thinking about a particular size of fence and then deciding if it's worth it to the farmer to increase or decrease the size of the fence by a little bit in terms of how much money that would end up costing them. Note, both of these are positive, which means that the cost and the area move in the same direction. Okay. Which says, if I want a bigger pen, it's going to cost me more money. If I want a smaller pen, it's going to cost me less money, which makes sense. These had better be positive. If they were negative, it would be weird. But you might see that this number from 2 to 1 has gone down and think that that means that something floating around is negative. And indeed, something floating around is negative, but that's actually the second derivative. Indeed, if you look at the second derivative, that works out to be this, and I don't really care about anything about this other than the fact that it's negative. And this negative sign here is telling me exactly what I observed, that the 2 is going down to 1 and then is going down, which is to say the cost of making the pen larger gets smaller as we make the pen larger. Okay, so that's a personal example for a farmer where we can interpret all of these things. I want to talk about this from a business example as well. Okay, so now let's suppose we own a small oil well, and that each day the oil well can produce and sell some amount of barrels of oil. And the cost of producing and selling those barrels of oil is given by this function. And so whoever owns the oil well has to decide every day how many barrels of oil to produce. And oil happens to be an apt real-world example for a few reasons. One is that the price of a barrel of oil fluctuates quite a bit day to day. For example, last time I taught this class, oil was selling for $45 a barrel, but now oil is selling for $65 a barrel. The second reason is that if you're producing oil, you can vary quite a bit how much oil you produce by how much work you put into doing it, particularly how deep you go, etc. So this is a real-world decision that someone would have to make, albeit the function would probably be a little bit more complicated. So I want to talk about and eventually answer this question about whether we should be producing 0 barrels of oil or 1,000 barrels of oil or whatever, how many barrels of oil we should be producing. And I want to make sense of what the function and the derivative mean and how they help us answer this question. So let's start by just evaluating the function c at 100. C of 100, if you plug in 100 to this function, will give you 6,000. And what that means, based on what our function means, is that producing and selling 100 barrels of oil will cost us $6,000. Now, please note, because we're imagining we own the oil well, we want this number to be small, not big, because that's money we pay, not money we make. Now, it turns out that our decision about how many barrels of oil we should produce is really not tied directly to the cost function. It's really tied to the derivative of the cost function. So let's calculate c prime of 100. Now, to do that, I'm going to need to know what c prime is, but I can take the derivative here. C prime of b is 0.5b plus 25. And so c prime of 100 is what I get when I plug in 100 here, which is going to be 75. The units here are going to be the units of the output over the units of the input. The units of the output are dollars, and the units of the input are barrels. So this is dollars per barrel. And what does this mean? This means that when we're producing 100 barrels of oil, each barrel of oil additional that we want to produce is going to cost us $75. Or we could equally well think of it the opposite direction. When we're producing 100 barrels of oil, each barrel of oil we produce fewer costs us 75 less dollars. And so the way I'll frame that is to say that both the previous barrel of oil and the next barrel of oil that we'll produce cost $75. Now, if you've taken Economics 130 here, which is the introductory economics course, you probably recognize the thing that is being described here. Namely, this is what economists call the marginal cost, or economists would usually just abbreviate this MC. And so this is the cost of the last unit that you made. And it turns out that production decisions are driven by the marginal cost. And indeed, the entire structure of the economy is driven by how the marginal cost behaves. So, for some goods, for example, as you produce more and more of them, the marginal cost goes up. And for some goods, as you produce more and more of them, the marginal cost goes down. Those two things act very differently. If the marginal cost goes down as you produce more, that's what would be called returns to scale, and that would in turn tend to lead to very, very big companies producing the good. Whereas, if, as in this case, the marginal cost goes up as you produce more, that's going to naturally constrain the size of individual businesses and lead to there being lots of small businesses, rather than one large giant conglomerate. Let's make sense of this in our particular example. So I'll remind you of what I said earlier. The price of oil today is $65 per barrel. So that is to say, I can sell all of my oil for $65 a barrel. That allows me to do this calculation. If I produce 100 barrels of oil, we said that will cost us $6,000. But it will make us 100 times $65. So we'll make $6,500. We'll pay $6,000. And so that means in total, we'll get a profit of $500 per day. Again, to run through that, if I make 100 barrels of oil, I sell them for $65 a piece, which makes me $6,500. But I had to pay to make those 100 barrels of oil, and the amount that cost me was C of 100, which was $6,000. That was the first thing we calculated. And so this money we take in, which economists would call the revenue, minus the money we paid out to make it, which an economist would call the cost, gives me the profit, which in this case would be $500. Now, here's the question. Is that good or bad? Could we do better? Now, I like, obviously, that this number's positive. That's great. If this number were negative, that would be very bad. But just because we're making money now doesn't mean we couldn't be making more money. And the key to understanding whether or not we could be making more money is to look carefully at the marginal cost. Namely, I want to look carefully at this number. That $75 is what I paid to get my 100th barrel of oil. That's how I should think of this. But then what did I sell that 100th barrel of oil for? Well, I sold that 100th barrel of oil for $65. Is that a good deal? No, that's a bad deal. I paid $75 in order to make $65. That's a bad exchange. So, because the marginal cost at 100 barrels of oil is $75, that means the 100th barrel of oil we produced cost us $75 to make, and then we turned around and sold that barrel for $65. But that means that on that barrel of oil, we took a loss of $10. What does that mean? That means that last barrel that we made, the 100th barrel, we shouldn't have made it, because making it cost us $10. So we want to make fewer than 100 barrels of oil per day. What if instead we tried making 50 barrels of oil per day? At 50 barrels of oil per day, the marginal cost, this C prime of 50, works out, because of our formula, to be 50. And so that's, again, in dollars per barrel. And what does that mean? That means the last barrel of oil cost us $50 to make, but we were able to sell it for $65. So that means we made $15 on that transaction. That means we want to make the 50th barrel of oil. We don't want to make the 100th barrel of oil. Somewhere in between has to be the perfect number of barrels of oil for us to make so that we're making as much money as we can. Now, I want to think about exactly what that means. Well, starting at 50 barrels, I want to make a 51st barrel, a 52nd barrel, and I want to keep going until what happens? Until I'm not making money anymore. So I want to keep going until the profit on the last barrel I made is 0. And why is it I want to stop at 0? I want to stop at 0 because if I keep going even further after that, I'm going to start making negative profit on the next barrels, and I really don't want to make negative profit. And so what we find is that we actually maximize the profit by finding where the marginal cost is equal to our sale price. So we want to produce until the last barrel that we produced makes us no money. That is to say, we want to produce until the cost of producing the last barrel was $65. Because at that particular barrel, we're breaking even. Namely, we're paying $65 to make $65. So when does this happen? Well, we can solve this by setting 0.5 times b plus 25. Again, that's just our function for C prime, equal to $65. And solving this, so that will give me 0.5 times b equals 40. So that will give me b equals 80. So what this says is we get our maximum profit when we make 80 barrels of oil. Ultimately, finding this derivative allows us to figure out how to make the most profit for this business. Okay, so I want to compare how that worked. So before, remember, our little oil well was producing 100 barrels of oil per day for a revenue of $6,500 that cost us $6,000 to make, meaning we made a daily profit of $500. Okay. If we now instead make 80 barrels per day, and that will give us a revenue of 80 times 65, which is $5,200. And do note that $5,200 is less than our revenue was when we sold 100 barrels. But our cost will also be lower, because this is C of 80. And if you plug 80 into this function, then you will get 4,600. Okay, and that's also in dollars. So on the 100 barrel a day paradigm, we were making $500 a day. On the 80 barrel per day paradigm, we're making a profit of 5,200 minus 4,600, which is $600 per day. So by changing how many barrels of oil we produced, we were able to change our profits and increase them by $100 a day. Okay, that's all for now, and that's all for this week. Remember, Test 5 is coming up on November 6th. It's going to cover sections 3.5, 3.6, 3.7, and 3.8. Next week will be Test 6, which will be the last test. And I'll tell you in advance, there are only 2 sections for Test 6, but the sections are a little longer. Then, after that, we'll have part of a week to review for the final, and then we'll have the final, and then the course will be over. But that's all for this week. I'll see you next week.